All right, welcome everyone to this focused exploration. We're looking at something really new in evaluating AI research progress today.
Yeah, we're diving into a project called PaperBench.
PaperBench. Okay, so for anyone needing the quick version, the elevator pitch.
Okay, the core idea. PaperBench is a new benchmark. It's designed specifically to test how well AI agents can autonomously replicate cutting-edge AI research papers.
Replicate them, like rebuild the whole thing.
Exactly. It uses these super detailed rubrics, actually co-created with the original paper authors, to check if the AI understands the paper, can write the necessary code, and crucially, reproduce the experimental results.
And the headline finding.
Well, it's pretty stark. The initial results show that even the best agent they tested only got an average replication score of about 21%.
21%, wow. Compared to what?
Compared to a human baseline set by ML PhD students who did significantly better. It really suggests, current AI still has a pretty long way to go for these kinds of autonomous, complex research tasks.
So think of this as us getting under the hood, really examining AI's research capabilities right now. It's not just about, reading a paper abstract.
Not at all. It's about deep understanding, implementation, coding, validation, the whole 9 yards. The creators picked 20 spotlight and oral papers from ICML 2024.
A recent conference, okay.
Yeah, top-tier stuff, covering a real mix of topics, deep reinforcement learning, probabilistic methods, you name it.
And what makes this benchmark different? You mentioned the rubrics.
The rubrics are key. They're incredibly rigorous. For each paper, there's this detailed hierarchical checklist, almost like a tree structure. It breaks down into over 8,000 individual gradable tasks across all the papers.
2,000, good grief.
Yeah, and they're not just pulled out of thin air. They worked with the paper authors themselves to make sure the criteria were accurate and reflected the real challenges of replicating that specific work.
Okay, that adds a lot of credibility. But grading 8,000 things sounds like a nightmare.
It would be, which is why they developed an LLM-Based Judge, an automated system.
And AI judging other AIs.
Pretty much. It compares the AI agent's replication attempt against that rubric. And they were thorough. They even created a separate benchmark called Judge Evil just to test how well their AI judge performs.
How did the judge do?
Quite well, actually. Their best judge hit an F1 score of 0.83 compared to human experts, which is, promising for being able to scale this kind of detailed evaluation.
Okay, let's dig into that replication challenge itself. What exactly does an AI agent have to do in PaperBench?
Right, so the main task is take a research paper, PDF and all, and from a completely fresh start, rebuild the experiments and try to get the same results the paper reported.
So it needs to understand the paper's core ideas first.
Absolutely. Understand the contributions, then develop a complete code base. They even have to provide a reproduced Dottish script so the evaluation environment can just run it.
And then run it, debug it.
Exactly. Run the experiments, troubleshoot any issues that come up. The creators really stress that these are hard tasks, often takes human experts days of work.
And you mentioned something crucial earlier. They can't cheat, right? No looking at the author's code.
Correct. That's a strict rule. If the original author's code is public, the agent is explicitly forbidden from using it or even looking at it.
Why is that so important?
Because it ensures PaperBench is testing the AI's independent ability to replicate. Can it truly understand the paper well enough to implement it from scratch? It's not just about finding and running existing code. It tests genuine comprehension and implementation skill.
Makes sense. It's a much tougher, more meaningful test. Now, these hierarchical rubrics sound central. Can you break down that structure a bit more?
Yeah, think of it like a decision tree almost. At the very top, you have the overall goal. Replicate the paper. Then that branches down into major components of the paper, which branch further into more specific requirements and so on.
All the way down to?
All the way down to the leaf notes. These are the most granular, detailed level, and each one has a very clear pass or fail criterion, like, did the code implement this specific equation correctly? Did the output match this specific number in table 2?
And you also mentioned weighting. Not all parts are equal.
Exactly. Each node in this tree structure is weighted based on how important that specific contribution or requirement is to the paper's overall claims and impact.
Ah, so the final score isn't just counting how many boxes got ticked.
No, it's more sophisticated. Scores are calculated by propagating them up the tree. A parent node's score is a weighted average of its children's scores.
I see. So that allows for nuance. Like, you get credit for nailing the really important parts, even if you miss some minor details.
Precisely. It means an AI can get significant partial credit for making progress on the core innovations, even if the full end-to-end replication isn't perfect. It reflects how research often works. Progress isn't always all or nothing.
Okay, that's a really smart way to structure it.
Yeah.
So down at that leaf node level, the actual pass-fail checks, what kinds of things are they looking for? You said 3 types.
Yeah, 3 main types of requirements at the leaf nodes: result match, execution, and code development.
Okay, result match. That sounds straightforward.
Kind of. It checks if the agent's submission after you run their reproduce.sh script in a clean environment actually shows evidence of replicating a specific result from the paper.
Evidence like?
The judge looks at the reproduce.sh script, the log files, reproduce.log, and any output files the script generates or modifies. It's looking for concrete proof. Did it produce the accuracy score reported in Figure 3, for example?
Got it. The final quantitative outcome. What about execution nodes?
Execution nodes are slightly different. They check if a particular step in the process actually happened when reproduce.sh ran.
Why is that useful?
Because getting a perfect result match can be really hard. So these nodes give credit for progress. Did the agent at least try to train the model on the correct data set? Did it run the evaluation script even if the numbers didn't quite match?
So it tracks progress towards the goal.
Exactly. The judge looks at the scripts, the logs, and sometimes the source code here to confirm that the required step was implemented and attempted.
Okay, and the third type, code development.
Code development focuses purely on the source code itself. Does the code appear to correctly implement a specific requirement described in the paper?
Even if it doesn't run correctly.
Right. This gives partial credit for correct implementation logic, even if there are bugs preventing execution or the final results don't match. The judge looks at readmes, documentation, and the code itself. For instance, did they correctly define the specified loss function in their code?
Wow, that's incredibly thorough. Checking the final result, the steps taken, and the code quality itself. But again, doing this manually seems impossible at scale. Hence the LLM Judge, the simple judge.
Exactly right. The sheer volume of checks and the complexity involved. Manual grading would take ages, many, many hours per paper per submission. An automated judge was absolutely necessary to make PaperBench practical.
So how does this simple judge work? What does it actually see?
It uses an LLM, specifically OpenAI's O3 Mini in their setup, to assess each leaf node independently. For every single check, the judge gets fed the full paper text, the whole rubric structure, the specific requirement it's currently grading, and importantly, the relevant files from the AI agent's submission package.
But agent submissions could be huge repositories of code, right? How does it handle context limits?
Good question. It doesn't just ingest everything blindly. It has a clever relevance ranking step. It looks at all the files in the agent submission and ranks them based on how relevant they seem to the specific rubric item being checked right now.
And then it just looks at the top ones.
Yep. It focuses on the top 10 most relevant files, feeding those into the LLM's context window. It's a heuristic, but it helps the judge focus on the most likely places to find the evidence it needs.
Smart. Okay, and there was also this PaperBench code dev version mentioned. What's that about?
Right, that came about because running the full replication experiments can be really demanding. You might need serious GPU resources, and runs can take a long, long time.
Expensive and slow.
Exactly. So PaperBench Code Dev is a lightweight variant. It basically strips out the execution and result verification parts. It focuses only on the code development nodes in the rubric.
So the judge only checks if the code seems right. It doesn't actually run anything.
Correct. No reproduce.sh execution, no checking log files for results. It just grades the code development requirements based on the submitted source code and documentation.
What's the advantage? Just speed and cost?
Primarily, yes. It removes the need for GPUs and cuts down evaluation time dramatically. They found using O3 Mini for code dev grading slashed costs by about 85%.
But it's less comprehensive, presumably.
Definitely. They acknowledge it's not as robust as the full benchmark,
All right.
but it provides a much more accessible way for people to evaluate an AI's ability to translate research ideas into code. Interestingly, though,
Yes.
they found only a weak correlation between how agents performed on code dev versus the full PaperBench.
Really? So writing code that looks right doesn't mean it'll actually work and replicate results?
Apparently not always, no. It suggests there's a significant gap between just implementing algorithms and actually getting them to execute correctly and reproduce specific scientific findings, that execution and debugging phase is critical.
That is a really interesting finding. Okay, so let's talk results. What happened when they unleashed actual AI models on the full PaperBench? Who did they test?
They tested some big names: GPT-4o, OpenAI's O1 and O3 Mini, DeepSeek R1, Claude 3.5 Sonnet, Gemini 2.0 Flash, a pretty representative set of recent powerful models.
And the winner was?
In their main setup, the top performer was Claude 3.5 Sonnet, but top is relative here.
How so?
It achieved an average replication score of 21.0%.
21%. Still sounds quite low for the best model.
It is. OpenAI's O1 came in lower at 13.2%, and the others were even further behind. It really drives home just how challenging this benchmark actually is.
So why were they struggling so much? Did they figure out the common failure points?
They did some manual inspection of the agent logs, which was quite revealing. Most models, actually, except for Claude 3.5 Sonnet in this case, had a tendency to just stop early.
Stop early, like give up.
Or declare success prematurely. They often finished way before the 12-hour time limit was up, either saying, yep, replicated, or nope, impossible problem. It suggested a real lack of long-term strategic planning.
They couldn't manage their time or break down the problem effectively over that longer duration?
Seemed like it. They didn't seem to grasp how to allocate effort effectively for such a complex multi-stage task. They also noted that O3 Mini, in particular, had trouble using the tools it was given, like the command line or a web browser, effectively.
Fascinating. So it's not just raw intelligence, but project management skills almost. What about the human comparison? How did the PhD students do?
Right, the human baseline. They had ML PhDs try replicating 3 of the papers. The best human attempt reached a score of 41.4% after putting in 48 hours of work.
Okay, 41.4% for humans versus what did O1 get on those same papers?
On that specific subset of 3 papers, O1 scored 26.6%.
So humans still significantly better, but maybe not orders of magnitude.
Right, and there was another interesting experiment. They ran O1 for an extended 36-hour period on those papers. What they saw was that the AI actually started faster than the humans. It made more progress initially, but the humans eventually overtook it. The humans kept improving and strategizing over the longer time frame, while the AI seemed to plateau or struggle to overcome hurdles that required deeper insight or adaptation.
So AI is maybe good at the initial sprint, but humans excel at the marathon of complex problem solving and debugging.
That seems to be one interpretation, yeah. It suggests current AI lacks that sustained strategic thinking and learning capability over extended complex tasks.
Very insightful. Now, they also tried tweaking the agent setup, right? This iterative agent.
Yes, precisely to combat that finishing early problem. The iterative agent setup basically forced the AI to use the entire allocated time. It also used different prompts designed to encourage a more step-by-step, incremental problem-solving approach, rather than trying to do everything at once.
Did that help?
It did, significantly for some models. O1 and O3 Mini saw substantial score boosts with the iterative agent approach.
Suggesting the way you prompt or structure the task for the AI really matters.
Hugely. But interestingly, the same iterative approach actually hurt the performance of Claude 3.5 Sonnet, the previous leader.
Really? Why would that be?
It's not entirely clear, but it highlights just how sensitive these models can be to the specific prompting strategies used. What works well for one model might not work, or might even be detrimental for another. There's no one-size-fits-all approach yet.
That complicates things. Okay, so looking forward, the creators are upfront about PaperBench having limitations, right?
Oh.
What are the main ones they see?
Yeah, they acknowledge a few things. One is the data set size, 20 papers, is a good start, but expanding it would provide broader coverage. Another major one is the sheer effort involved in creating those detailed rubrics. It's very labor-intensive, requiring deep expertise.
Hard to scale up quickly then.
Right. And they also point out that the LLM Judge, while good and getting better, still isn't perfect. It's not quite got the same level of nuanced understanding as a human expert grader yet.
So what are the plans for future work? Where does PaperBench go from here?
Key priorities include finding ways to automate, or at least semi-automate, the creation of those detailed rubrics. That would be huge for scalability.
Makes sense.
Also, continuing to improve the accuracy and reliability of the AI judges is crucial. And there is an interesting point about investigating how agents might learn to game benchmarks like this, strategically under or overperforming. Understanding that is important for keeping the evaluations meaningful.
Yeah, the adversarial aspect of benchmarking.
Exactly. Ultimately, they see PaperBench as a really important step towards developing more rigorous ways to measure AI's ability to do actual complex R&D work autonomously.
So wrapping this up, what's the big picture message for you, our listeners, who are tracking AI progress? What does PaperBench tell us?
I think PaperBench gives us a much-needed, realistic view. It shows that while AI is definitely getting better at things like understanding text and generating code, the ability to autonomously take a cutting-edge research idea and independently replicate and validate it, well, that's still a really significant challenge.
It's a higher bar than many other benchmarks.
Definitely. The level of detail in the rubrics, the focus on execution and results, it gives a much deeper insight into capabilities than just, say, checking code syntax. The differences between models, the human comparison, these are really valuable data points for the field.
It really highlights the complexity of measuring true scientific capability in AI. And it raises that fundamental question. As these systems get smarter, how do we design evaluations that truly capture their potential to contribute to science?
That's the core question, isn't it? And the good news is the PaperBench team has open sourced their code and the paper is available. So if you're interested, you can really dig into the details.
We definitely encourage you to check out the PaperBench project if this has piqued your interest. It's a fascinating snapshot of where AI research capabilities stand today.
Absolutely. It shows we're making progress, but also how much further we need to go before AI can truly partner with us in advancing the frontiers of knowledge. It's just the start of figuring this out.
A challenging but exciting road ahead. Thanks for joining us for this deep dive today.